Good morning, good afternoon, good evening, everyone who are watching our open class Zoom series. My name is Zizi Shili, and I use she, her, hers pronouns. I'm currently the manager of global programs, and I'm just feel really, glad to be here to give a brief introduction of one of our amazing global faculty, Dr. Ruopeng An. Dr. An is a tenure associate professor at the Brown School and also the Division of the Computational and Data Science at Washington University in St. Louis. He also served as the lead faculty in data science at the Brown School. In 2018, Dr. An was elected as the fellow of the American College of Epidemiology. He also published over 185 peer-reviewed articles in international peer-reviewed journals with a total impact factor of over 700. He provides peer reviews for over 120 international academic journals. One of his studies was also listed by Time in the year of 2015's 100 most important discoveries in the field of health. In 2018, he accepted the invitation of the World Health Organization as one of the primary authors of the report of the first global conference on air pollution and health in Geneva. He was also included in Ellisville's 2021's list of the world's top 2% scientists. Last year, he founded the AI and Social Science public lecture series. He currently teaches 3 graduate level AI courses at Washington University. Let's welcome Dr. An to give us a wonderful lecture today. Welcome.
Yeah, thank you so much, Zizi, Sarah, and Dale. I truly appreciate all your support and to welcome everyone. Great. So first, what is AI? What is artificial intelligence? Some of us may believe that AI is an almighty know-all, or others may think, well, AI must be the most sophisticated mind, maybe Sherlock Holmes plus Albert Einstein, or maybe plus William Shakespeare. And others may think, well, AI must be a math genius trying to solve like the most complicated math questions in the world. But really, no, there are different definitions for AI, but AI is just trying to automate intellectual tasks that are normally performed by human beings. So those are the cognitive tasks that we human beings take for granted that AI now try to catch up. For example, a few cognitive functions that we are doing on a daily basis, probably on a minute-by-minute basis, are the following. We have visual spatial ability. So I'm a person who is terrible in direction, but some people are really good at it. So basically, we need to recognize the images and the visuals and recognize the directions as we go. And language comprehension and speech, right? We need to, no matter what language you talk, we can understand each other, we can convey our own ideas, and we can also understand other speeches. And also ability to learn new information. As you are now listening to this, the sample lecture, you try to grab new information, understanding some knowledge points and trying to make sense of the talk as we go. And we all have memory, right? No matter it's good memory, bad memory, we know what happened in the past. We had a track of the history leading to the present. And we are also creative. We are very proud of our creativity. For example, no matter it's painting, performing arts, or solving a math question, or playing chess. We use our imagination and creativity in everything we do. So those are the common cognitive functions that we human beings take for granted. But actually, it is really hard for machine to be able to understand and perform those cognitive functions. And that is exactly the aim for artificial intelligence. So some of you may have heard of the Moravec's paradox. It is comparatively easy to make computers exhibit adult level performance on intelligence tasks or playing checkers. but really difficult or impossible to give them the skills of a 1-year-old when it comes to perception and mobility. So those cognitive skills that we take for granted are really hard for machine to learn. And AI, believe it or not, has been everywhere. So AI is sometimes people regard artificial intelligence as the new electricity because it's a general technology that has been applied to many different domains. So now I can't really think of one domain or social sector that has not implementing some sort of AI. Of course, the mileage differs, but to some extent, the AI is already in every corner of our society. Even if you have not learned about the technology, you must have interacted with artificial intelligence in one way or other. For example, if you ever used a search engine, Google or Bing or whatever search engine that is your favorite, underlying they use the AI-powered recommender system. Or if you like social media, or watch YouTube videos or watch movies in Netflix, actually those your friends, the movies, and all those are recommended by the artificial intelligence system. If you purchase items from Amazon or Shopify, those food items, those products were actually recommended by AI. And social media, Facebook, Twitter, we network in the social media domain, and actually most of the algorithms were AI-driven. And if you want to exercise, you wear wearables, a Fitbit, Apple Watch to measure your exercise habits or measuring your sleeping patterns, and the underlying algorithm are also AI-driven. If you want to talk with a machine, for example, in a companion chatbot or therapeutic chatbot, actually underlying they use AI-driven language models. And nowadays, for example, banking and fraud detection algorithms to prevent suspicious transactions were all driven by AI systems. So about 20 years ago, before the AI really dominate the market, we had a discussion about digital divide. Some of you may have remembered that at that time we argued that people's ability to manipulate computers to use internet or not is a important factor for people's social welfare, for people's financial status. So people who do not know how to use computer or internet tend to be left behind because they can't really leverage the power of internet and computer to benefit themselves. But nowadays, 20 years later, we want to argue that now we are facing the AI divide. So basically, people who know how to leverage the power of AI is advantageous. On the other hand, people don't know how to use AI to leverage the power tend to left behind. And probably we are at the very beginning of this AI divide, and we are going to see the gap between those who know AI and don't know AI tend to further deepen down the road. And well, AI, I will always enjoy talking about this analogy that AI like a hammer. So AI is just a tool. Well, we can't really say that there's evil AI or there's beneficial AI because tool is a tool, right? Like a hammer, right? You should use hammer to nail down a nail, but you shouldn't use hammer to knock someone's head, right? So the AI is the same, that people can use AI to benefit society, but on the other hand, well, they are also potentially dangerous and evil use of AI. So the difference between the AI and the hammer is that AI is more complicated, right? Or probably magnitudes of more complicated than a hammer. So on a hammer, it's easy for us to regulate because, well, we just need to write in the regulation that someone should not use hammer to knock someone's head, right? Or maybe think other scenarios that a hammer can be harmful. But, well, it's not that difficult for us to exhaust the potential options. But for AI, because AI is still developing very quickly, it's really hard for us to know what AI cannot do. So therefore, the regulations are always one step or two steps behind development of AI. There are always going to be some advanced use of AI that cannot be covered or have not been thought of by regulators or policymakers. So that is the difficulty for regulating AI. And many of you probably heard from the news media, social media, that AI is increasing maybe disparity or biases, or AI is discriminating against social minorities, or AI algorithm is biased, right? There's all sorts of problems, consequences of unethical, irresponsible use of AI. And that is a very critical issue that we try to address. And others argue that AI is taking over the world, right? So when I was a child, I always enjoyed watching the Terminator series, and I was really scared one day the Terminator would come and grab me. So there are similar scary stories that people tend to believe. That maybe one day AI is taking over the world. But, well, no, I would argue maybe the possibility is not that high. So here we quote René Descartes, who is a famous philosopher, once said, "I think, therefore I am." Right. So it means that, well, AI on the one hand have very high intelligence. There's no doubt about it. But on the other hand, the intelligence doesn't necessarily equal to self-awareness. It means that, well, if the AI doesn't recognize itself as a being, then AI potentially cannot protect its own right if it has rights, right? So therefore, if intelligence is not the same as self-awareness, and if the machine does not have self-awareness, or at least now, we don't have evidence to show the machine have self-awareness, then maybe it's not going to benefit itself by destroying the world. But of course, this is an open question. And other people argue that AI is taking away jobs, right? So that argument has a long history. So if we go back to 200 years or 300 years ago, during the Industrial Revolution period, we had the similar argument that machines were taking away people's jobs. And to some extent, it was true, right? Because the power loom, for example, replaces human labors, and many people got jobless because it was cheaper to use power loom for production than use human labor. But, well, if we took a look of what happened after the Industrial Revolution, the machines, on the one hand, replaces human being to some extent, but also actually increases the overall number of jobs. And if we take a look of what happened to Amazon over the last 10 years, so Amazon is a pioneer in adopting AI technologies. And as we see, as the business grow in Amazon, from 2010 to 2021, on the one hand, there was an exponential adoption of AI technology, and on the other hand, we see exponential growth of the number of employees hired by Amazon. So it is possible that AI, to some extent, can replace human beings in some specific job requirements, but overall, it may create more job opportunities elsewhere. So what is the difference, fundamental difference between artificial intelligence and what we have been doing over the past probably 50 or 70 years using this traditional rule-based algorithms? So here is why AI is dominant and why AI is really useful. So considering the classical programming, the rule-based algorithm that we need to explicitly write using algorithm to write all the rules for how we are going to manipulate a process, and output the data. So what we feed into the machine are the rules that we have to explicitly write and also data. And then the output of the classical programming are the answers. Right? So we know it's extremely hard to write explicit rules. For example, if I ask you how to differentiate a dog from a cat, a dog image from a cat image, right? Then you say, well, that was easy. Maybe the dog was larger than cat, or maybe the dog had more curly hair than cat, or whatever that you could think of the difference between dog and cat. But it is really true. A dog necessarily larger than cats? Of course, it's not true because there are larger cats. There are smaller dogs, right? If you talk about the dog ear and the cat's ear, well, there are a lot of differences, but it's really hard to say what are the rules, are the principles that can differentiate a dog's hair from a cat's hair, right? So therefore, if I ask you to explicitly write those rules or principles to differentiate dog and cat, you are going to quickly come up with a mess, right? Because there's just the rules are complicated, multidimensional, and also conflict with each other constantly, right? And if I ask you, can you write rules to differentiate 1,000 different categories, right? Dog, cats, airplane, bushes, and then well, that is not possible, right? So it is extremely hard to write those explicit rules to differentiate things. And here comes the rescue of AI. So instead of inputting the rules and data, the AI asks you to input data and answers. And we feed the data and answers to the machine, to the AI algorithm, and output the rules. So which one is easier? Well, writing the rules to differentiate dogs and cat images, or just providing a few examples, right? Providing a number of dog images, a number of cat images, and then label each image, which one is a dog, which one's a cat, and then that machine figure out the rules, right? So that is why AI is useful, and AI really alleviates a lot of burdens from our human cognition, because the machine now is in charge of coming up with the rules. Another example is scam email screener. So all of us nowadays, I believe, in our email boxes, we have some functionality of automatically deleting or quarantining the junk email, right? And underlying most of the algorithm are AI driven. So consider on your left-hand side, if you want to write explicit rules to differentiate whether this email is a spam or is a regular email, then you may say, in your algorithm, in your principle, maybe one criteria, if this email contains a word of lottery or have 3 question marks, so those emails should be spam. And other emails are regular email. But is that true, right? Can you exhaust all the possibilities? Most likely not, right? And over time, well, the patterns for the spam email change over time, right? So on the right-hand side, if I ask you to develop a machine learning algorithm, artificial intelligence algorithm to differentiate those 2 emails, well, what you need to do is to provide a number, say 500 spam emails, another 500 regular emails, and you feed both into the machine learning artificial intelligence algorithm, and the algorithm is to learn from the data and come with the rules to differentiate spam from regular email. Of course, the algorithm is not 100% correct, right? There are The machines, like human beings, make mistakes, but well, operational wise, it is extremely easy for machine learning to learn about those rules that human beings are trying to write all those rules. And over time, machine get better and better in understanding the pattern and being able to differentiate those two types of emails with greater accuracy. So I know we use a lot of different terminologies, AI, machine learning, and deep learning, how they are related. The artificial intelligence is the overarching concept or idea, including both the rule-based algorithm as well as the machine learning algorithm. So therefore, the AI is the largest concept, and machine learning is part of artificial intelligence, or we say machine learning is the modern AI. Because it doesn't use rule, it uses algorithm to learn from the data to come out with the rules. And then deep learning is part of machine learning. So deep learning uses a specific, we call artificial network to represent complex data. So here is an example comparing the machine learning with the deep learning. We call machine learning often as shallow learning because it doesn't have layers of neural network. It's just use explicit algorithm to try to understand mostly tabular data. Tabular data means the data that you manipulate most often with a certain number of rows and a certain number of columns. And deep learning, or sometimes called deep artificial neural network, are excellent in learning more complex and unconventional, or we call it big data, right? So the images, the visuals, audios, text, and speech. So those are the data that deep learning shine, because deep learning uses underlying really complicated neural network structure to try to learn from the data. So that is the difference between machine and deep learning. And in terms of the types of artificial intelligence systems, there are at least three major types. We have unsupervised learning. So for example, you provide images of a cat and images of a dog, and you feed into the algorithm, but you don't tell the machine which image is a dog and which image is a cat. So the machine is going to learn from the dog and cat images and probably make sense of that without human supervision. So the second type is called supervised learning, where we provide the images of a dog, image of a cat together with their corresponding labels to the algorithm. So the algorithm is trying to understand the relationship between the dog and cat images and their corresponding labels. So we call it supervised learning because we human beings have to tell the machine which image is a cat, which image is a dog, because the machine have no prior knowledge on that. And the third type is called reinforcement learning, where the machine learn by incentives. So here I'll give you a analogy. Think about how a baby is going to learn to stay away from the fire. On the other hand, always try to grab a bottle and drink some milk, right? So the way we train the baby to do that is that if the baby go close to the fire and he or she may feel the warmth, or the fire is extremely hot, and the baby learned in a hard way, and the next time the baby is trying to stay away from the fire, right? And baby gets satisfaction from drinking milk, so that is how the baby learn to approach milk. So think about the machines. We can create incentive, and this incentive telling the agent, the machine agent, to stay away from the fire. Every time the agents go to the fire, the agent has this incentive, maybe minus 50 points. And then every time the agent goes to the milk bottle, we provide 50 positive points. And the goal for the agent is to maximize the number of points over time. So guess what? The agent is going to be smarter and smarter and trying to stay away from the fire and always approach the milk bottle. So the AI models are getting bigger and getting smarter and getting more complicated. Now, some of you may have heard recently the Chat GPT, right, which is the state-of-the-art language model developed by OpenAI that actually were trained based on the GPT-3 model. So over the past 10 years, starting from 2012, when we have those Albert models, the size of models increases exponentially. Now we have some of the state-of-the-art language models have over 1 trillion parameters, right? It's more than the total number of neurons in our human brain. And of course, those models are becoming better and better in understanding, for example, human language and being able to communicate with you or even write an entire essay for you. And specifically, this is not an exhaustive list for sure regarding AI applications in health and social sciences. We use AI nowadays for disease diagnosis using CT scan or MRI imaging data. We can provide precision care, patient healthcare, customized patient healthcare using AI algorithms. We can use machine learning algorithm to predict the onset of a disease, which tend to work a lot more precise than the previous scores or indexes that we developed. And we can perform, for example, sentiment or trend analysis on social media data, Twitter, Facebook, Instagram, to analyze people's sentiments and people's perceptions of, for example, certain policies or a social phenomena. And we can use theme or topic identification, topic modeling to understand deeper regarding what are the themes that were covered among, say, 100 years of New York Times publication, right? So if we human beings were tasked with screening 100 years of New York publication, probably take forever, right? And the therapeutic social chatbots now are increasingly used to either entertain people by talking with them, or actually sometimes can provide clinical assessment and mental health consulting for people who have mental illnesses. And regarding the job market pertaining to artificial intelligence jobs, now we see a very clear trend that interdisciplinary social, behavioral, and health scientists with modern AI and data science skills are in surging demand and highly valued nowadays on the job market. So the current national average annual salary for a data scientist is about $120,000 in the United States. And while the data is a little bit old, probably now is even higher. And the US Bureau of Labor Statistics had a recent prediction that the data scientist jobs will increase by about 28% or 11.5 million through 2026. So on the one hand, we do see a really high demand and increasing demand for interdisciplinary data scientists. But on the other hand, we also need to recognize that there's a huge gap in artificial intelligence training. So especially in the social science and health field, we see very few social work or public health schools and a program that provide systematic training on AI and big data analytics. No, many of the programs, if you take it by name, you will see that, well, they emphasize data science, but if you take a look at the curriculum, they are still very much in the traditional statistics, not really related to artificial intelligence. So traditionally, the AI training is mostly only available in statistics or computer science programs, which primarily focus on theories, algorithms, software development, or applications in engineering, whereas the social, behavioral, and health students and researchers who have a lot of interest in data science and AI They have to take courses in a statistics department, in a computer science program, and the training they receive is often less relevant and applicable to their own professions or their real-world tasks at hand, unfortunately. So the Brown School at Washington University in St. Louis is uniquely positioned in filling this gap. So on the one hand, we have truly interdisciplinary programs. We have public health, social work, social policy as three majors. And we also have deeply rooted strengths in quantitative modeling. We have about 100 faculties, and half of faculty focuses on quantitative modeling and data analytics, and the other half focus on qualitative analysis. And the Brown School has also extensive real-world research opportunities. We have 17 research centers that harbor a rich environment for students to learn and apply modern data analytics for tackle some of the really complicated, perplexing social and health problems. So here, I want to take a little bit of time to try to dismiss some of the misperceptions regarding how you learn about artificial intelligence. So there are 5 major misperceptions that I've seen over time when I talk to students when I'm delivering my AI courses. They are too much math and statistics. Second, too much programming. Third, need too much data to be useful. And fourth, you need substantive computation resources that are expensive, that you can afford. And finally, you can't compete with professional AI scientists on the job market, no matter how much you learn. So let's talk about each of those misperceptions. So one, too much math and statistics. Yes, most AI algorithm is statistically driven. It involves a lot of math, a lot of statistics. But on the other hand, I would argue most AI practitioners, probably 99% of the AI practitioners, don't need to know the math and statistics behind every single algorithm. So the intuitions and experiences are more important. For example, in my course, I don't think there's added value by showing or letting you derive the theorem for bias variance trade-off, right? I see little value about it. Maybe if you are majoring in a PhD in statistics, you should do that. For an interdisciplinary data scientist, I don't see that is beneficial. On the other hand, understanding the intuition behind the bias variance trade-off is fundamental. It's really, really important for you to be able to apply those algorithms correctly, efficiently. So modern AI is more engineering than math proofs. Actually, there are a lot of algorithms commonly used in modern AI that are not proved at all. But people justify them over time that those algorithms works. So it's more of an engineering trial and error rather than a strict, rigorous math proof. And some argue that AI is too much programming. Yes, you need to know some programming. You need to learn about probably Python, right? But there are nowadays, thanks to the Python and many high-level APIs, it's become increasingly easier for you to program AI. There's no code or low-code programming that are developed and greatly simplified AI programming. For example, if you want to develop a random forest, right? A state-of-the-art machine learning algorithm. Nowadays, two rows of code. Okay? The first row that you define, you're going to use a random forest regressor, and the second step, you feed your data. Okay? That's it. And if you want to develop a artificial neural network model, you think, well, this must be complicated. But again, 3 lines of code. The first line is that you define, for example, a sequential model. And second, you compile the model, defining the loss function, optimizer, and metric. And the third step is to feed the model to the data. And that's a deep neural network model, right? So not too hard. And some others argue that, well, we need a lot of data. We need millions of rows of data to train a model. I don't have that data, so AI is not good for me. Well, the foundation models that the model, the large language models, large computer vision model, they were trained for sure based on terabyte of text and millions of images. But the good news is that nowadays, you don't need to train the AI models from scratch. Most likely, we are going to use transfer learning so that we can stand on the shoulders of giants. So this is not exaggeration. So this is happening now, and we are using transfer learning every single day. So you almost never need to train a model from scratch. Because you've used those big models developed by others, thanks to the open source that are available to you. Now you only need very few data to train the state-of-the-art model. Instead of using 14 million images from ImageNet data, you probably need only a few hundred images. Instead of training the machine learning model, the deep learning model using all the Wikipedia text or 10% of what is there in the internet, there's zero-shot training, there's few-shot training that sometimes you don't need to provide any data for the model to work pretty well. So here, for example, if we use the GPT-2 model, the language model, a very large language model as to do some prediction, I provide the prompt, life is like a box of chocolates, and that the GPT-2 model complete the rest. So guess what? This is I don't train the model at all. And the model output is it opens into itself, it fills it with life, and it's all about sharing, right? Beautiful passage I myself probably couldn't write. And do you really need large computer resources? Most likely, well, it depends, right? So we know that training large language models or computer vision models, most likely you use the GPU, and GPU-powered computer is expensive. But on the other hand, you don't need to have your own GPU-powered computer. There are some free GPU computing and very inexpensive GPU services available by large high-tech companies, Google, Kaggle, and Amazon and Microsoft. They all provide the online computing platforms, either free or charged by service. So they are very affordable. And so basically nowadays, I have all my data, I have all the computation happen on the cloud that I won't need to have a computer. I can just use my iPad or sometimes my cell phone for the computation. So some other argue that you can't compete with professional AI scientists. Well, no, you may never need to because the job market really value people with interdisciplinary background. For example, if you are a public health researcher, if you're a social worker, but you know enough about how you apply AI algorithm to your own domain. So that is actually what the market is looking for. At the Brown School, we proudly offer the artificial intelligence and big data analytics for public health certificate program. We call the AIBDA program. The program consists of 2 full credit courses and 2 one-credit skill labs. And it provides you all the foundation from the beginning all the way to advanced artificial intelligence applications. So the program focused on practicality or application. So we don't want to learn too much, dealing too much with math and statistics. On the other hand, we have a important focus on application, especially to public health and social work and other social domains. So through training, the students will master Python programming for data science, learn state-of-the-art machine deep learning models, and being able to implement responsible ethical AI applications to solve real-world social and health problems. And program graduates will become competitive in the job market for interdisciplinary data scientists and positions that demand sophisticated data analytics skills. So the courses are the following. In the spring, we offer the skill lab of data ethics. I think now they changed the wording a little bit. Maybe it's called algorithm biases. And also in the spring, we'll provide the full course taught by myself. It's called Applied Machine Learning Using Health Data. And in the fall semester, we have another one credit skill lab called Introduction to Python for public health data analysis. And in the fall, I offer the other full course, Applied Deep Learning Using Health Data. So here is just a brief description about what we cover in the two courses, the machine learning and deep learning. Now, as you see, we won't have to go much into detail, but as you see, the topics are very relevant to social sciences, and we cover a extensive ground in machine learning and deep learning. So some of the topics that we cover are very advanced. Some of the models that we implement were actually invented maybe a few months ago, a few weeks ago, or maybe a few days ago. So we are going to keep track of the new development in artificial intelligence and trying to cover as much as we could. And we also offer data ethics, where you are going to learn about how to implement those ethical AI, responsible AI. On the other hand, how to mitigate the negative impact of algorithmic biases and try to involve human in the loop in the decision-making process. And if you want to further sharpen your Python programming skills, we offer a skill lab for you to learn about basic programming so that you feel more comfortable when you learn machine and deep learning. So all the Brown School students enrolled, no matter whether you are an MPH, MSW, or MSP, or PhD programs, you are eligible to take the certificate program with no additional cost. So as long as you can fulfill these two required courses and two skill labs, we will offer you the certificate. And interested students should consult with advisors for program enrollment, but because you want to make sure that you fulfill all the requirements together with your degree, right? So being prepared for enrolling in this program and talking to an advisor probably is the first and required step, so that you can make sure that you can fulfill all the requirements successfully. If you don't want to take all the sequences or the two courses into skill lab, you only want to take like a single course as an elective, that is completely possible. So the enrollment is entirely flexible. So you can choose to take one or more courses, or you want to take the sequence. So you can self-decide what is the best of your interest. Just to recap what we covered, we know that AI is already everywhere, no matter whether we recognize or not. And we are one of the AI divide. On the one hand, we see the rapidly increasing labor market demand for interdisciplinary data scientists. On the other hand, we also see the gap, and that's the reason why at the Brown School we developed the AIBDA program to help you navigate the complex the road that allow you to transition from a public health researcher or social work researcher or social policy researcher to an interdisciplinary data scientist. So we argue that AI may be easier to learn than you thought, owing to the open source high-level APIs, and hopefully we have clarify some of the misunderstandings and misperceptions about AI. And also, finally, the AIBDA certificate program is just designed for Brown School students who are interested in becoming a future interdisciplinary data scientist. So that's all I want to say in this very short but fully packed sample lecture. So let's open up to questions. Thank you.
Thank you so much, Dr. An. I learned so much, and I know all of our attendees did as well. And feel free to drop your questions or comments into the chat, and Dr. An will field those.
Yeah, feel free to raise any questions. It won't have to be directly related to this lecture. Just any general questions about data science. If you you have you need some clarifications or have any relevant questions, just feel free to ask.
Can I ask a really quick question? I know that many Brown School students or WashU community member or outside, members are taking AI related courses or postmaster certificate with you. Could you please share some examples of your projects that you are working with or you work with students or colleagues in the past?
Yeah, so that's a great question. Actually, though, my courses, deep learning and machine learning courses are on high demand. So every time we have to increase the cap 2 or 3 times to be able to accommodate everyone. And we have students from a variety of disciplines, in the postmaster certificate program, as well as in the courses teaching at Brown School. We have students from a variety of different domains: nutrition, kinesiology, medicine, and public policy, even engineering, design. So you name it. The people, we see a huge demand from different sectors and different domains that people are all interested in learning the data science, the technologies. And those technologies are very much applicable to very different domains. It doesn't really matter actually whether you're learning design or you're learning public health. The fundamental models are very similar, and the knowledge you learn is very much transferable. In the postmaster certificate program, we have people from all over the world. We have 50 plus students enrolled in this program, and we had quite a wild journey in artificial intelligence. And for the different projects, I have many ongoing projects, probably 10 plus ongoing projects. We use, for example, we analyze the Twitter data to track the people's sentiments about soda taxes and manual labeling regulations. We have computer vision programs and apps that we develop to identify different food products. We have evaluated some chatbots in terms of capacity to answer body weight, body image related questions. We have machine learning algorithm trying to predict your true height and weight based on self-reported height and weight. So there are just many ongoing projects. If you want to learn more, I have a separate talk about the ongoing projects.
And I just wanted to note, this was mentioned in the chat a little bit, but someone asked if that certificate program is open to people outside of Washington University and the Brown School. And Dr. An mentioned the postmaster's certificate. And I do just want to clarify that that is open to anyone, whether you are in the Brown School at Washington University or outside of Washington University. We have a postmaster's certificate in artificial intelligence led by Dr. An, and then we have a selection of, I believe, 7 other topics, and I'll drop a link to that in the chat as well.
Yeah, thank you, Sarah and Zizi, for mentioning that. This is a great question. Yes, we for Washington University students, but not Brown School students, you can still take my machine deep learning course as an elective, but you cannot, unfortunately, take the certificate because the certificate is only open for Brown School students. But really, I don't think that matters too much, because that really you want to learn the techniques. That is the most important thing. If you are outside of WashU, as Sarah mentioned, we have the postmaster certificate program. We had a successful last fall, and we are going to open the certificate program again this fall. So keep tuned. There's I think there's the link that you provide. You can go into there and maybe sign in with your name. So we have a record when the program is open. You'll be notified. And that program is open to people all over the world.
Can I ask something really quick? So here it's probably a little bit confusing for people who are not familiar with the certificates. So for AIBDA certificate, this is the program we are open to the Brown School, but we also have another postmaster, AI postmaster certificate, which is open to basically everyone. So if you have any further questions and about this program, you are welcome to reach out to me or Dr. An directly, for further questions or.
Yeah, that's a great comment. I know it's kind of confusing because the naming, but this is my email address. I'm just sending through chat. So feel free to email me if any information is confusing or you just want to know more about a particular program. Let me know, and I'm more than happy to send you some further information. Okay, so any other questions, anything that you want me to clarify, or any further comments? And again, you know where to find me. So if you are at WashU, you feel free to drop by. So this semester, I'm offering the applied machine learning using health data. So we meet every Monday in the classroom in person. So you can find the class information through the course listing at WashU, and feel free to come by and say hi. And I'm teaching the deep learning in the fall together with the postmaster certificate program. And the postmaster certificate program is offered online. So that is going to be the best way to meet everyone, no matter whether you are in St. Louis physically or not. So there are many ways that I'm also offering the AI open classroom series that happen every second Thursday. So Sarah, maybe you could share with others about that theory later, providing the links. So the second talk is going to be on February, where we talk about some philosophical or ethical issues about artificial intelligence. And we often invite distinguished speakers to talk about their unique encountering with AI from both industry and academia.
Yes, thank you, Dr. An. And just to close out, as Dr. An mentioned, we have many great programs coming up on Open Classroom. We'll drop the link in the chat for our upcoming programs. We have more in our curriculum showcase where you can get more sample lectures like this from Brown School faculty. And then as Dr. An mentioned, we also have an AI series. So if that is something that you're interested in learning more about, you can attend upcoming AI programs, or you can go to our YouTube channel and watch recorded videos from past sessions with Dr. An and other scholars working in the field of AI. Thank you all for being here today, and have a wonderful rest of your day. Bye, everyone.
Thank you, everyone. Bye.
Thank you.